This is Savant from Northern Blades, here to present our solution to the problem statement AI-driven traffic management system, which comes under the domain urban solutions. So we have made a HTML dashboard for the visualization of how insights of our server works. It's not the main dashboard. So every traffic intersection where lights are present have cameras in each lane. So our trained model, which we have trained using Indian traffic data, receives these live feeds from camera directly. So this YOLO V11 medium segmentation model then calculates the polygon density of each lane and sends data to server. Now in other models, the cars which are farther from the camera appears very small, which causes error in density calculation. But our model uses bird eye view for video calibration. So it doesn't make any difference between nearest or farthest vehicle. Now the server, after receiving the density payload, then calculates the pressure score, which is nothing but the density into how much time the lane is waiting for. So the lane with the highest pressure score receives priority and is next made green. The green time gets decided by our special formula considering minimum green time of at least 15 seconds and maximum wait time of not more than 180 seconds. Now there are many edge cases which happens on Indian roads, but we cannot explain all of them here, so I will explain the most important ones. So our model calculates speed also and the count of vehicles too. So if the current green lane is going to be red, but our model sees a huge amount of vehicle is coming through that lane and coming above 30 kilometers per hour of speed, then it gives a 8-second extension, 8 seconds extension. Like here we got the extension of 8 seconds. It is restricted of maximum one extension per lane only. Next is that before giving green to any lane, our system checks if fifth camera, which is looking at the center of the intersections, like the center box area, which is present in the intersection. So if its density, like here is 20%, if its density is more than 95%, then it's turned all lane to red, and its density reduces to 65. And if its density reduces to then 65%, it gives priority to the last chosen lane. Otherwise, it would not open the gate and then inform it to our traffic dashboard. Next is the emergency vehicle override. So our server tracks ambulances or emergency vehicles via MQTT server pings. If any ambulance is near 500 meters of an intersection, it starts tracking it. So we have made a visualization for it also. Let's select lane 3, then the dispatch ambulance. So the simulation is progress. So as it has started tracking it, our mobile channel has started tracking it, as it reaches 250 meters, then the next priority is set to that lane only, overriding the score math. But it does use round robin of 15 seconds each to every lane for reducing wait time congestion, so that it doesn't get restricted. As ambulance reached 150 meters, then it flushes out that lane. That is the now that you can see that the third lane is open because we have dispatched the ambulance in it. System failed or there is some network connectivity issues, then the normal currently used system of hard-coded or round robin system will be implemented directly. So from here, via HTTPS request, it sends data to our main dashboard. That is our main traffic dashboards. It is accessible only to the officials which are controlling here. So here, one intersection which is connected to our this model is ITO section. So let's just search ITO. And from here, we can get to the command center of this intersection. So these are the live feed which will be connected via RTSP from MCD server directly to reduce the latency or load on our actual model server, right? Density calculations and wait time and green time can be seen here. If we dispatch ambulance, it will be shown here also. And this is the center. We could not get the video, so here is just a simulation of it. Also, here is the manual override where the officials can control lights according to that to clear a very long congestion, because we cannot leave everything on AI only. Also, there will be notifications for any error or hardware issues, or even if an animal or an accident has happened on any lane. So it will provide the notification to the server, to the dashboard manager. Here we can see the peak hours of each lane is the highest or anything. And here CO2 emissions saved and the time saved can also be seen here, and which is calculated according to the vehicles. And here we can also see that the which lane was the most congested or which lane was the most busiest at what time, that peak time here is 1 p.m. and also from here we can check the hardware vulnerabilities. So there are there are some security arrangements and optimizations which we have done. We have tried all the edge cases which our model solves, which can be seen or thought can in Indian real traffic, and this is done to make it fully deployable into the real traffic of Delhi. So thank you.